profound reform of the liability regime in the European Union, what we try to do is to identify to which extent this kind of technologies, clearly combined in collaborative, complex, multiple actors, user-centric ecosystem, they had different features that could impact to some extent in the basis of the liability legal regime. In order to do that, we decided to map the analysis from a legal lens, from a legal perspective on this ecosystem on the basis of the following distinctive features. In order to see, as I will show you in a minute, to which extent this characteristic have any impact on the element, on the basis that liability rules work on. So when I see your outcome, your project, your application, your expected outcomes or already implementation of your project, I clearly see the encapsulation, the crystallization of the following characteristic. In all cases, they are significantly complex. In the design, in the operation, either the algorithm or indeed the mechanical structure of this project. They have multiple actors participating in this collaborative manufacturing design or structures. We have also a plurality of parts, a plurality of components. This level of complexity, that of course is not new. We have many pre-digital ecosystems that could be considered as well significantly, notably complex. However, what we can see is that this complexity, this evident complexity of emerging technologies-driven ecosystem, in addition to the other characteristic that we will say in a minute, clearly aggravate, clearly make or render extremely difficult and unpredictable the applicability of the existing liability rules. Which are these other characteristics that create a concept, a perception of disruption in the use of emerging technologies and the traditional liability regimes? The opacity. This very well-known idea or mantra or motto that we are living in a black box society because this ecosystem driven by AI solution and algorithm, they have a high level of opacity, a lack of transparency, a very low level of explainability for the end user, create the idea that, or create the perception that this system, in case of being involved in accusation of damages, they are not going to facilitate the possibility of identifying and determine the cost and the causal link. In addition to that, and that is something that probably you are extremely and particularly concerned about, is the problem of vulnerability. Vulnerability, that is a very interesting second side, reverse side of the power and the strength and the potential of this system. More powerful these systems are, more vulnerable they could be. This vulnerability I'm talking about is essentially related to cybersecurity vulnerability. If we're talking about the application of the system, for example, in the aerospace sector, the risk arising from a vulnerability of this system is of a tremendous magnitude. So that clearly increased the perception of risk and the exposure to the risk of liability. There are clearly three other components that I see extremely relevant in the case of the SeCoIIA project. All these systems are what we call open system, open ecosystem, in the sense that these systems are not inanimate, they are not close to the environment. On the contrary, they are open to the environment, they are permeable to the environment, and they are indeed interacting with the environment and accommodating to the environment input when it's necessary. This idea of upgrade or updating of the system as a mechanism to prove your diligence is going to be a very relevant element that we will discuss in a minute. The other element that is extremely important is that when we conceived this tremendously, incredibly complex technological ecosystem, we realized that this ecosystem are indeed empty bodies unless we have data flows. The data dependence of these systems is vital. Without data, these systems do not work at all. But that is probably not the worst scenario. The worst scenario is what happened when these systems are working with a set of data that is insufficient, inaccurate, or biased. Data dependence is probably one of the most obvious vulnerability in liability terms from these AI-driven collaborative manufacturing complex technological ecosystem we are talking about today. And the last element that is also fascinating and is probably a matter of a scale more than simply an absolute element distinguishing this kind of ecosystem is the idea of a transition from purely automatic ecosystem to increasingly autonomous ecosystem. To the extent that this ecosystem incorporate deep learning, machine learning, and other learning techniques, we are clearly infusing the system with a high and increasing level of unpredictability. And as you know very well, unpredictability, in combination with the other distinctive features, is clearly touching on the key element that we traditionally use in liability to allocate risk and attribute liability. With unpredictability, we are clearly rendering difficult to know exactly how to use the causation link to allocate the risk to the actor that is in the best position to mitigate the risk, to control the risk and mitigate the negative effect. And at the same time, we could be misplacing the negative consequences of liability. So my first understanding of your project is that in many, many cases, if not all, your outcomes, the implementation of this project may participate of this combination of characteristics that we consider challenging features, distinctive features, challenging the application of the traditional liability rules. And why is that? Why this characteristic that clearly described, outline why these ecosystems are different or significantly different, why is that important for the purpose of liability? As you can see in this summarizing matrix, you can see on the left side the most important pieces of the liability puzzle, the liability legal puzzle. And on the other side of the matrix, you will see what are the characteristics that we have been discussing before that could have any kind of impact on the effectiveness of these elements that we need to apply the existing liability regimes as we know, as we are familiar with. If we think about, let me give you a couple of examples in order to go immediately further and to use some more specific example. As we can see, if we need, for the purpose of applying the traditional fault-based liability regime, we need damage, we need fault, and we need causation. As you can see in the case of causation, the combination of the previous distinctive and disruptive characteristic clearly distort, at least the traditional way we have learned to apply causation. Because to find a link between the damage and the faulty party is difficult, and is becoming extremely difficult when we have a plurality of actors involved, when we have a highly opaque black box, when we have unpredictability triggered by learning techniques. In all these cases, it's going to be difficult to identify if there is a causation. And if we cannot identify properly the causal link, the problem is that we might be in a situation of either being totally unable to allocate risk, would probably lead to the unprotection, completely unwanted unprotection of the victim, or on the contrary, we could be in a scenario where we are allocating risk and damages in a way that is clearly wrong, that is clearly inadequate, that is not indeed properly aligned with the incentive and the capabilities of the involved actor to prevent this risk. Let me just give you another example, and I will immediately continue with some ideas for the purpose of illustrating this main statement. If we talk about defective product, Defective product liability, that all of you know, is another very important element in the harmonization effort in the at the European Union level to have a common framework for liability in Europe. If we take a look at the Defective Product Liability Directive, that, as you know, was adopted in the 80s, there are elements in this Defective Product Liability Directive that they are not clearly fitting into the technological ecosystem we're talking about today. The concept of product is indeed the first obstacle that we have to remove. Is really an AI-driven ecosystem a product? Because if not, we are probably outside of the scope of application of the Defective Product Liability regime. Even more, the fact that this ecosystem has caused damage could be considered and attributed to the existence of the defect, as defect is described and analyzed in the Directive for Defective Product Liability. For example, a defect in relation to information, a defect in the design. Can we consider that a biased or a low data-based decision is considered a defect? And let me just add another element that for me is indeed fascinating. Is the idea of what is the time point from which we are going to consider that the producer is liable or not for the damages caused by this complex ecosystem. That is the idea of when the product was put into circulation in the market. And why is that so important? Because if you agree with me that these kind of ecosystems are open ecosystems, that they are interacting with the environment, that they are accommodating to the environment needs, that they are a kind of, let me use this metaphor, a kind of living creatures, that they are evolving in the market, this time point in the timeline probably is becoming quite irrelevant. Probably is even more is unfair, because once the product is put into the market for circulation, after that point, from that point onwards, maybe this system has been, as Ivo mentioned, personalized by the end user, maybe has been learning from the environment, maybe has been let's say, inputting data that were incorrect or biased. So even if the producer has made the best effort to ensure the reliability, the quality, the safety, and the security of the ecosystem, the natural evolution of the product in the market is indeed the reason why this system has become clearly dangerous and risky. So this, in my opinion, these two first slides clearly capture the two main messages that I would like to discuss with you today. The idea that these ecosystems are complex, opaque, vulnerable, open, data dependent, and increasingly autonomous, and to which extent this mere description of the ecosystem has indeed a legal reading, has indeed a very clear legal impact. So taking that into account, let me just just a few minutes before concluding, Ivo, let me know if I have to conclude earlier. The idea is to show you what are the possible solutions. So are we completely unable to apply the existing dogmatics, the existing rules, the existing solution in our legacy liability regimes? Do we need totally new solution, or we can't adapt the existing solution to the new reality? Let me show you some of the solutions that we discussed and proposed in the European Union expert group when we adopted their report, and some of them were clearly taken by the proposal for a liability system for AI-driven system adopted in the October 2020. Others were clearly disregarded or simply not taken into consideration at the moment. Let me show you some ideas. Okay, if we take into account what are the components that we have available in our liability puzzle, we have the contractual liability, we have tort law and fault base, we have a strict liability, and we have the defective product liability regime. What can we do with this product, with this component? The first idea is that this super provocative, very thought-provoking idea of legal personality for robots and autonomous AI-driven system was at the moment postponed delay, we consider that is not providing an effective solution for the purpose of attributing liability in complex ecosystem. So what can we do? The first idea is, can we apply the existing fault-based liability? Considering that the fault-based liability first is the basic liability approach in all the member states, and second, it is not totally harmonized at the level of the European Union. So that is very important to take that into account. Can we apply that? The main idea is, yes, we can and we should. So we should consider fault liability as the basic liability approach for complex ecosystem. But how can we apply and interpret the duties of care, the due diligence, as Ivo mentioned before, in the context of a complex ecosystem? We have to consider that the due diligence in the case of ecosystem should be crystallized or articulated or expressed and manifested by the operator in the following activities or tasks: choosing the proper ecosystem, monitoring the operation of this ecosystem, and ensuring the proper maintenance and update of the ecosystem. That is the ways to protocolize and express the due diligence of the operator. And then, if I may, two ideas. The first idea is there any defense for the operator? Okay, two possibilities. The first possibility is the third-party interference. And that is, in my opinion, a clear reference to cybersecurity attack. But this third-party interference defense is not absolute. That depends to the capacity of the operator to prove that this third-party interference, for example, a cyber attack, a hacking attack, could not be prevented, even if the operator has applied the due diligence expected from him or her, choosing, monitoring, maintenance, and updating. And the other idea that for me is very important is to which extent the idea of autonomy, so the idea that this autonomous system creates unpredictability in relation to the outcomes, could be considered a defense for the operator. And the decision, the policy decision in the group and also in the regulation, the proposal for the regulation is the same. No, it is not a defense. The operator cannot allege that because the system is increasingly autonomous, it is not liable for the consequences. So as you can see, we have the main basis for liability on the fault-based liability regime with this idea of a reinterpretation of the traditional duties of care. Let me just conclude with two more ideas. The strict liability, just to conclude, Ivo, the strict liability is not considered the main regime, but exceptional regime that we apply when we can identify high-risk application based on AI, as listed in the proposal of regulation that I mentioned before. Who is liable in this case? Again, the operator. And who is the operator? Is a new actor. Is the actor where two elements converge: control over the operation and the risk, and benefit from the operation of this risky ecosystem. Maybe I can conclude with a final idea. In the expert group, we proposed a new concept, the concept of commercial and technological unit, precisely for the purpose of identifying the kind of ecosystem that you are developing in your project. This idea that we have ecosystem integrating different actors, different components, different technologies, to which extent we could consider all these technological ecosystem that could be technological because they are interacting each other, but also commercial, in the sense that in order to produce the product or the service to the market, you need to interact together. We propose this idea for the purpose of facilitating all the liability action. If you are a commercial and technological unit, you should held liable on a jointly and severally basis in relation to the end user. So you are acting as a unit in the market. This idea, however, has not been adopted clearly, at least explicitly, at least by the proposal of regulation. But I think it might be a good element for the further discussion. Thank you very much, Ivo. happy to discuss later with all of you.